In last video lecture, we discussed about the proof of work concept in respect of Bitcoin. So in today's video lecture, I will talk about the basic concept of proof of work, how it came in the picture, and I will take two video lecture. In this first slide, I will talk about some background and then the cryptographic approach by which the proof of work we can. So let's start. The idea of proof of work was, we can say it was in 1992, and it was for avoiding the junk emails. So the idea was, whenever we want to send an email, then we have to do some work, and definitely it will avoid the junk emails. So the sender of junk email will be discouraged because they have to work something, and then only that email will be sent. So the very first feature we can say for the proof of work is asymmetry. So the proof of work mechanism should be moderately hard but feasible for the service requester. And the second one, the work must be easy check for the service provider. So that at the recipient side, just for the verification of that, it should be very easy. It may be completed. It should be completed within seconds. So service requester will get discouraged to fork the work, but the service provider can easily check the validity of the work. So the cryptographic hash function, we know that the very property of a cryptographic hash function, the third property is it should be puzzle friendly. So in the cryptographic primitives video lecture, I talked about these hash function and the property of hash function. If you are not aware, then please see those video lectures. So the cryptographic hash function, as I said, the property of this type of function is it is puzzle friendly. So suppose we propose a puzzle for the, say, for example, in the previous example, I talked about that if you want to send a mail, then you have to do some work. So suppose we proposed a work that suppose we have two values, X and Y, and suppose you are using any cryptographic hash function like SHA, and the X and Y is given to you, and you have to find out this value K. That means a message X is given, and after computation, what will be the hash code, that is Y, is given. The hash function which is applied to find out the hash code is also given, and you have to find out this value K. So definitely this work is not an easy work. It is a difficult one, but not infeasible. If I say this Y is given and find out the X, then it is infeasible. But as a certain part of the message X is also given, and you have to find out this K, so it is not infeasible. So this is the one example for the proof of work. We can propose this work. However, once you have a K, it will be very easy to verify the challenge, because if you know X and if you find out the K, then computing this hash code is a very easy task. So the very feature which is required for this proof of work, that the work must be moderately hard but feasible for the service requester, and the work must be easy check for the service provider, both satisfied. So this cryptographic hash function can be used for this proof of work. So in hash case, used this concept, a proof of work that can be added with an email as a goodwill token. So let's talk about this hashcash proof of work concept. A textual encoding of hashcash stamp is included in an email header, and proof that sender has expended a modest amount of CPU time calculating the stamp before sending the email. And it is unlikely that sender is a spammer, because he have to expend a modest amount of CPU time for calculating that. The sender can verify the hashcash stamp very easily, as I discussed in the previous slide. And any change in the header requires a change in hashcash. And the only option for that will be the brute force attack. So try to find out each and every way to find the same. So definitely it will be not feasible for any spammer. So just I have taken an example. The hashcash is included in the email header, and it's look like this is the certain example. The general format is the version, how many number of bits we want. So version, suppose for example 1, number of 0 bits in the hash code as resultant one we want say 20, then date. So this is the 4th May 2021. So this is the, we have taken year, then month, and then the day. So this is date, the resource, this is the email ID. This is my email ID. Just I have taken, for example, optional extension. It is blank here. Then a string of random characters, say this, and last one, the counter. So any sender will construct the header like this. The sender initialize the counter value to a random number. Any random number can be initialized by the sender. And the sender will compute the, say, suppose SHA1, 160-bit SHA1. The hashing algorithm is used of the header. If the first 20 bits of the hash are all 0, then it is accepted. Otherwise, use a different counter value and try again. So sender will select a counter value, compute the hash code. If he get the first 20 bit 0, then it's okay. Otherwise, he will take a different counter, and then again same process will be repeated. At the receiver side, the receiver will check the date. Suppose we say within 2 days it is allowed. The email address that will give the resource from where he is receiving. The random string, it should not be used repeatedly within a certain duration to avoid the replay. And compute the 160-bit SHA1 hash of the entire received string. So if the first 20 bits are not 0, then simply he will be in impression that it is a invalid. So for the receiver, it is very easy to validate it, to check it. And for the sender, it is the difficult work. He have to select a counter and compute the hash. And when he will get that first 20 bit zero, then he will be able to send that message. So this is a very good example for the proof of work. On average, the sender will have to try to about 20 hash value to find the valid header. And you know that possible hash values are to the power 160. So the 20 bits at the beginning, it's not a easy task. But for the recipient, it may take just microsecond to just validate it. And the chance of randomly selecting a header with 20 bits at the prefix is 1 in 2 to the power 20, because these are the possible values. And so you know the probability concept. So 1 in 2 to the power 20. So as I talked about the Bitcoin, you are aware about this slide. You know that we use some block hash, previous block hash, Merkle root, and nonce value in the header of a blockchain. And we can say that find out 20 bit, the difficulty level, suppose we say 20 bits should be 0. It may be another value also. So this type of difficulty we can propose for as the proof of work for the miner, you can say. So we talked about the Bitcoin proof of work. Mostly in the Bitcoin, double SHA-256 hash function is used. By default setup we have for the miner 10 minutes. They collect all the transactions and start mining by using the proof of work. And no miner will be able to control the Bitcoin network single-handedly, because the probability of getting a proof of work is low. So it is difficult to say which miner will be able to generate the block. And basically it is needed to avoid a single one domination on the network. So this is the source of the whole information I shared. You can check this link, hashcash.org. You can download, and you may check for a different number of 0-bit target, and you may have the practical exposure for that. So enough for today. In the next lecture, I will talk about the second part of this proof of work. So enough for today. Thank you.